Section 4.5 is on completing the square. You might recall from Algebra 1 the square root property. That is, taking the square root of each side of an equation in order to solve it. Let's take a look at an example of how that works. So here we have the equation x squared minus 12x plus 36 equals 25, and we need to solve that using the square root property. So basically I want, if possible, to make each side of the equation a perfect square. And indeed, x squared minus 12x plus 36 is a perfect square trinomial that will factor into x minus 6 squared, and that equals 25. Now I take the square root of each side, and on the right hand side when I do that I want the positive or negative square root. So that gives me x minus 6 equals plus or minus 5. I can write that as two equations. X minus 6 equals a positive 5, and x minus 6 equals a negative 5. And adding 6 to each side, I get x equals 11 and x equals 1. Let's take a look at another example here. X squared plus 8x plus 16 equals 20, and we need to solve that using the square root property. So this side, the left side of the equal sign, is going to be a perfect square trinomial, and that will factor into x plus 4 squared, and that equals 20. Now I take the square root of each side, and a positive or negative over here. That leaves me with x plus 4, because the square and the square root cancel each other out, equals plus or minus the square root of 20. Square root of 20 can be simplified into 2 square root of 5. So I have x plus 4 equals positive or negative 2 square root of 5. And then subtracting 4 on each side, we would write it like this. X equals negative 4 plus or minus 2 square root of 5. And realize that that is two answers, negative 4 plus 2 square root of 5 and negative 4 minus 2 square root of 5. Now we're going to use the square root property to do something called completing the square. And this is where you make one side of an equation a perfect square trinomial. In our previous examples, those already were perfect square trinomials. But we're going to make it a perfect square trinomial so that we can then use the square root property. So in order to do that, I'm going to move my existing value of c to the right of the equal sign. I'm going to find a new value of c that makes the left side a perfect square trinomial. And to do that, I'm going to do b divided by 2 and then square that. And I will add that to both sides of the equation. I can now factor the left side because it will be a perfect square trinomial, and then use the square root property and solve for x. Let's take a look at several examples here. Oh, before we do that, let's practice finding c. So this says find the value of c that makes x squared plus 12x plus c a perfect square trinomial, then factor it. So x squared plus 12x plus c, my new c is going to be b over 2 squared, or 12 over 2 squared. 12 divided by 2 is 6. 6 squared is 36. So that's the value of c that makes this a perfect square trinomial. Now I need to factor this, and because I know it's a perfect square trinomial, I know that that's going to factor into an x plus, because there's a plus in the middle, 6, the square root of 36 squared. Okay, now let's start completing the square. So solve this quadratic equation by completing the square. First step is to take my existing c and move it to the other side. So I'll have x squared plus 4x equals 12, adding 12 to both sides. Now I need to find a new c that's going to make this a perfect square trinomial. To do that, I take half of b and square it. So half of 4 is 2. 2 squared is 4, so I add 4 here, and I have to add 4 here. Now this side of the equation will factor into x plus 2 squared, and this side of the equation becomes 16. Now I can use the zero product property. Take the square root of both sides. This becomes x plus 2 equals plus or minus 4. That gives me two equations. X plus 2 equals a positive 4. X plus 2 equals a negative 4. So x equals 2. And x equals a negative 6. Now our next example, 3x squared plus 10x minus 8 equals 0, is a little more complicated because completing the square only works when a is equal to 1. So in order to do that, I need to divide everything by 3. I have to start with x squared. Okay, so that's going to give me x squared plus 10 thirds x minus 8 thirds equals 0. Remember, 0 divided by anything is equal to 0. Okay, a little more complicated, but we can do this. So let's move our existing c to the other side by adding 8 thirds to both sides. Now I need to find my new c. So remember, c is half of b over 2 squared. So my existing c is 10 thirds. Now dividing that by 2 is the same thing as multiplying it by 1/2. So half of my existing b squared is going to be 10 over 6 squared, or 5 over 3 squared, or 25 over 9. Now, leave it as a fraction. If you want to do some of this in your calculator, you can, but make sure you turn that decimal back into an improper fraction. So I'm going to add 25 over 9 to both sides. Okay. This side of the equation is going to factor into an x and a plus and whatever the square root of 25 over 9 is. And that's 5 thirds. Squared equals, and then grabbing your calculator, do this in your calculator, it turns out to be 49 over 9. Now I take the square root of each side, and now you can see why I wanted you to leave it as a fraction. So now I have x plus 5 thirds equals plus or minus square root of 49 over 9 is 7 thirds. That's going to give me two equations. Oops. X plus 5 thirds equals a positive 7 thirds, and x plus 5 thirds equals a negative 7 thirds. Subtracting 5 thirds from each side, I get x equals 2 thirds. And then subtracting 5 thirds from each side, I get negative 12 thirds, or negative 4. So it's just a little more complicated. If a is greater than 1, just divide by a and keep everything as fractions. And here's our last example. Let's go ahead and move that 25 to the other side. So x squared minus 6x equals negative 25. Find our new c, take half of b, which is going to be negative 3, and square it, which is 9. So I'm going to add 9 to each side. Factor this side. That's going to turn into x minus 3 squared equals a negative 16. Take the square root of each side. Make it positive or negative. So I have x minus 3 equals plus or minus. Now, square root of negative 16, square root of negative 16 is going to be 4i, because the square root of negative 1 is I, square root of 16 is 4. Now when we add 3 to both sides, your answer is going to look like this. X equals 3 plus or minus 4i. So this, your answer in this case is two complex numbers, 3 plus 4i and 3 minus 4i. So in this section we took a look at how to complete the square by using the square root property and ran into the case where a is greater than 1. It can get a little messy because you have to have a equal to 1 in order to complete the square.